299,792,458 meters per second. Fast. Incredibly fast. The fastest thing we've ever known. Fine, we all know that number. But have you ever truly stopped, taken a deep breath, and asked yourself, why? Why is that specific number the ultimate limit? Why can't you go faster, even by just 1 meter per second? What is actually stopping you? Is it some kind of cosmic friction, an invisible wall, or just an arbitrary rule made up by nature? Think about it. If you have a powerful enough engine and an infinite supply of fuel, shouldn't you be able to just keep accelerating forever? Most of us have never really wrapped our heads around this. We simply accept it as a matter of faith, because Einstein said so, because the textbooks told us to. The speed of light is the cosmic speed limit. It sounds prestigious, sure, but that's not an answer. And that's just repeating dry, soulless words. Do you accept it because you believe in authority, or because you actually understand the hardware running behind this reality? When you start asking why seriously, when you dig beneath the shell of definitions to find what is truly blocking you, you'll touch something incredibly strange. Something fundamentally different from every everyday experience you've ever had. It's so alien that it will shatter and rebuild everything you thought you knew about space and time. Mark my words, the speed of light isn't just a speed. It's not a record meant to be broken. It is the structure of the universe itself. It's woven so tightly into every fabric of space-time that going faster than light becomes logically meaningless, much like trying to walk north of the North Pole. You can't. Yet there's simply no path leading there. Let me show you where the truth lies. We'll start with something incredibly simple, something every child sees every day. Things fall. You drop a pen, it falls. You drop an apple, it falls. Exactly 16 feet in the first second without missing a beat. That's what Galileo meticulously observed. But have you ever wondered if this mundane act of falling and that grand speed of light share the same root? Get ready, because the journey to crack the universe's greatest mystery begins right with the things falling beneath your feet. Think about this very carefully with me. Actually, the moon is falling. It is falling toward the Earth at every moment, every single second. But the only reason it doesn't collide with us is that it is moving sideways at an incredibly high velocity. Imagine you throw a ball horizontally. It travels a certain distance and then falls to the ground. You throw it harder, it travels a bit further before falling. If you could throw that ball fast enough that the curvature of its falling path matches the curvature of the Earth's surface perfectly, the ball would fall forever without ever touching the ground. It would just keep going around. It falls, but it keeps missing. It falls, but it constantly misses the target. That is the very essence of an orbit, a perpetual fall in a state of constantly missing the mark. This is where Isaac Newton stepped in with an insight that transcended his time. He knew the moon was about 240,000 miles from the center of the Earth, which is 60 times farther than the distance from the center to where you are standing right now. Newton asked a bold question. What if gravity gets weaker with distance? He proposed the inverse square law. This means that if you are 60 times farther away, gravity must be 60 squared times weaker, which is equivalent to being 3,600 times weaker. Now, let's do a little math to see the wonder. On the ground, everything falls 16 feet in the first second. So, at a distance 60 times farther away like the moon, how much should it fall? Take those 16 feet and divide it by 3,600. What is the result? It is exactly about 1/12 of an inch. Newton calculated this number and cross-referenced it with actual astronomical observations. And do you know what? It matched with haunting precision. The moon is indeed falling toward the Earth at exactly 1/12 of an inch every second. That was a moment that changed the entire course of human history. With a single thread of logic, Newton connected the falling apple in his garden to the grandest and most distant celestial bodies in space. The universe was no longer a collection of scattered, mystical, or mythological pieces. It became a consistent system, a giant machine that we could predict and understand to the core. The intellectual satisfaction at that moment was absolute. We thought we held the key to everything. However, just as confidence in Newton's mathematics reached its peak, as we began to apply it to decode even more distant planets, a strange discrepancy appeared. A tiny, tiny crack in that perfection, and it was this very crack that led us to the true mystery of light. But remember, science never stops at satisfaction. As our measurements became increasingly precise, the tests for Newton's laws became more stringent than ever. And then, a crack appeared. Scientists of that time began observing the moons of Jupiter. They used their incredibly stable movements as cosmic clocks to verify everything. According to Newton's calculations, everything should have been perfect. But the truth was otherwise. Jupiter's moons seemed to be playing games with us. Sometimes they were running 8 minutes ahead of schedule, and sometimes they were 8 minutes behind. 8 minutes. In the world of mathematics and physics, that is a massive discrepancy, an insult to precision. Something was wrong. Was Newton mistaken? Did the law of universal gravitation only work on Earth but not out there? While everyone was in a panic, mister, a rumor stepped in with a bold assumption. Instead of throwing out Newton's law, he placed absolute confidence in it. He noticed an odd pattern. The moons ran faster when Jupiter was close to Earth and slower when Jupiter was far away. Why would distance affect the observation time? Rumor's answer shook the entire scientific community. Light does not propagate instantaneously. It takes time to travel from one point to another. Think about what just happened. We found the speed of light not by measuring it directly, but by trusting another law. Because of that confidence in gravity, when the results didn't match, instead of doubting the old, rumor saw a completely new phenomenon. Without Newton, it might have taken us centuries more to understand that light has its own velocity. But this was the starting point for something I call an avalanche of discoveries. Each new discovery becomes a tool to unlock even greater doors. A continuous, rapid process spanning 400 years and still hurtling along at breakneck speed to this very day. Once the number for the speed of light was in our hands, we began to test it in reality. And you know what? That is exactly when all your common logic begins to completely collapse. Now, we have that number. But this is where things get truly insane. Brace yourself, because what I'm about to say will challenge every sense and common logic you've accumulated since birth. Imagine you are standing on a high-speed train, moving at half the speed of light. You hold a flashlight and turn it on, shining it forward. According to everyday logic, the velocity of light at this moment should be the speed of light plus the speed of the train, right? If you throw a ball on a train, its speed adds up. But with light? No. Absolutely not. You measure it, and it's still $299,792,458 meters per second. You make the train go even faster, 90%, then 99.9% of the speed of light. You measure it again. It is still exactly that number. The speed of light does not add up. It doesn't care how fast you are hurtling along, and it always stands still at a single value for every observer. This should literally blow your mind. Why does the universe operate in such an irrational way? Einstein was the one who saw the truth behind this paradox. He realized that if the speed of light is an unchangeable constant, then something else must accept change to compensate, and that something is time and space. Listen closely. Time and space are not fixed and rigid frames. They are flexible. They bend, stretch, and mold themselves to ensure that the speed of light stays the same for everyone. The faster you move, the slower your time actually passes relative to someone standing still. Your clock's hands move slower. Your heart beats less frequently. And not just that, the space in front of you actually contracts. Distances shorten. This is not an optical illusion. Nor is it a machine error. It is physical reality. The universe adjusts itself, bending both space and time just to protect the invariance of the speed of light. But the strangeness doesn't stop there. If you try to accelerate an object with mass to reach the speed of light, you will slam into an impassable physical wall, not because your engine is weak or because you lack fuel, but because as you get closer to that limit, your object becomes more stubborn against acceleration. We call this relativistic mass increase. Your inertia starts to skyrocket. The faster you are, the harder you are to push even faster. And as you approach the threshold of light speed, your inertia approaches infinity. To push an infinite mass faster, you would need an infinite source of energy, and infinite energy simply does not exist in this universe. That is why no matter with mass can ever touch the number 299,792,458 meters per second. Only massless particles like photons can move at that speed. In fact, they have no choice. They must always move at that speed from the moment they are born until they disappear. So the ultimate question is, why? Why does the universe set a speed limit? The answer might leave you feeling frustrated, yet full of wonder. Because the speed of light is not actually the speed of light. Light is just something that happens to move at that speed because it has no mass. The true nature of this number is the speed of causality. It is the maximum rate at which information and influence can propagate through the structure of space-time. If you could go faster than light, you would be able to receive an effect before the cause happens. And you could send a message to the past and prevent yourself from being born. That is completely illogical and breaks the consistency of reality. The speed of light is the hardware, protecting the logic of this universe from collapsing. Do you think these are just sci-fi hypotheses? Not at all. We verify it every day. Those GPS satellites flying high above are moving very fast and are in a region of weaker gravity than Earth. Time passes differently for them than for us. If engineers didn't program them to compensate for the time dilation caused by relativity, the map on your phone would be off by miles within a single day. Or look at moons, subatomic particles created in the upper atmosphere. Their lifespan is extremely short. They should have decayed long before hitting the ground. But because they hurtle at near-light speed, as time for them slows down enough that they complete the journey to the ground for us to observe. The speed of light is a hard limit, an ironclad law measured and confirmed by thousands of experiments. It is the key that unlocks the most bizarre and profound beauty of the universe, showing us that the reality we live in is truly stranger and more magnificent than any science fiction movie. Look back at the journey we've just taken. It started with an apple falling in Newton's garden, crossed the mysterious 8-minute discrepancies of Jupiter's moons, and ended with Einstein bending the very fabric of space and time. This isn't just physics. This is the greatest journey of humanity, the quest for truth. This universe isn't dry or lifeless like the formulas in a textbook. It is vibrant, strange, and so beautiful it takes your breath away. The fact that we, tiny creatures on a small blue planet, can understand, measure, and predict the deepest laws of existence, that is the true beauty of science. You know what? Truth never promises to bring you comfort or ease. Sometimes it stuns you. Sometimes it makes you feel infinitesimal against the vastness of space-time. But it brings you enlightenment. Or it gives you the key to see reality as it truly is, rather than what we have long imagined. And remember, this avalanche of discoveries hasn't stopped. We are still hurtling forward, still searching, and still avalanching at an unimaginable speed into the new frontiers of knowledge. The truth is still out there, right in front of you, waiting for you to ask the next, why?